Welcome students. Here we will see a question from the topic arithmetic progression. Question is very interesting as well as very important. Here question is the pth, qth and rth terms of an AP are a, b, c respectively. Show that q minus r into a plus r minus p into b plus p minus q into c. This is equal to 0. Okay. So here we will use a formula for general term of an AP. Correct. Which we write general term Tn is equal to a plus n minus 1 into d, where a is first term and d is common difference Okay, so you see what is given here. Pth, qth and rth term are a, b, c, means pth term is a, correct, and with the help of this formula we can write pth term is equal to of course here pth term is a and you are using first term is a, so better to use another letter for this first term. Okay, so let us write first term here a1, correct. So pth term is a, and with the help of this formula, pth term means a can be written as, by this formula, a1 plus p minus 1 into d. Similarly, we can write here qth term is b. Here mentioned qth term is b. So this b can be written as, by this formula, this is qth term, this is nth term. So in place of tn we are writing n here. So in qth term, in place of n you will write q. So this is a1 plus q minus 1 into d. Similarly, rth term is given here. Rth term is c. So c is, by this formula, rth can be written as a1 plus r minus 1 into d. Suppose this is relation 1, this is relation 2 and this is relation 3, correct. Now we have to prove in left hand side this expression is given, in right hand side this is equal to 0. So first of all let us try to get q minus r into a. So q minus r into a is equal to how much? We can do it very easily by subtracting relation 2 and 3. We can get very easily by relation 2 and 3. Okay, so 2 minus 3 gives us, in left hand side, b minus c, and in right hand side a1 will be cancelled out. So we will get here q minus r into d. Okay, here you see we are having the term q minus r into a. So let us multiply both sides by a. So or we can write a into b minus c is equal to q minus r into a d. Very clear? Okay. Similarly, also for getting r minus p into b, r minus p will get by 3 minus 1. So 3 minus 1 gives, in the left hand side, 3 minus 1 means c minus a. C minus a is equal to r minus p into d. This minus 1 will be cancelled out when subtracting. Or here r minus p into b, so multiplying both sides by b. So b into c minus a is equal to, in right hand side we will get r minus p into b into d, correct. Okay, and third term is here p minus q into c, where from we will get p minus q, p is here, q is here. So by 1 minus 2 we will get it. 1 minus 2 implies that a minus b is equal to p minus q into d. Okay, in this term you see this is P minus Q into C. So we'll multiply both sides by C. We will get here A minus B into C is equal to P minus Q into C into D. Correct? Now we will add these relations number 4, 5 and 6. So adding relation number 4, 5 and 6. What we are getting? If we first write right hand side, then here D will be common and we will get here Q minus R into A plus R minus P into B plus P minus Q into C. Okay, and in right hand side we will write these expressions. So we can multiply these expressions also while we write it. So this is AB minus AC, AB minus AC, and this is BC minus BA, BC minus BA, and this is AC minus BC, or you can write, yeah, it is correct, AC minus BC. So plus AC minus BC. Now right hand side you see all the terms will be cancelled out. Here this AB will be cancelled out, this minus BA, minus AC will be cancelled out, this plus AC, and plus BC will be cancelled out, this minus BC. So in right hand side we are getting this much is equal to 0. Okay, but if this either D is equal to 0 or this expression is equal to 0, D cannot be 0 here, otherwise AP will not be formed. Correct? So dividing both sides by D, we will get Q minus R into A plus R minus P into B plus P minus Q into C. This is equal to 0. So this result has been proved here. Understood? Okay, nice. Very simple and interesting question. And at the same time, this is very important also. So thank you very much for watching this video. Wish you all the best.